So now for the recording, basically we're gonna go continue the process of building the combat game, and we're gonna look at how do we do raycasting. So this is like pistols and assault rifles would be using their primary fire would be with a raycast attack as opposed to a projectile attack. So let's go through. So raycasting. So what we need is to start with the idea of array. Array is a line starting at a origin and going in some direction, effectively to infinity if necessary. And Unity has array data structures. And one of the things that's useful to know, it has a get point method that returns a position based on a distance provided. So you have an origin and a direction, which are two different vectors. I mean, two vector. I mean, we're dealing with vector threes in 3D space. And so get point will get based on some distance from that origin, the origin of the ray, it will give you a point in space based on that. So here is, so let's jump. So files this week. There are three files. I'm just going to bring these over here just one moment to show you. There's a Unity package. There's a Ray example file and a Raycast example file. So let's bring those in. So let me bring up my project. And I think, yeah, so the package has those two files already. So we'll import them. Bring out. Come on, Visual Studio. It's just a file. So here we go. So essentially what the code on these is basically this here. So we have to create the new keyword to create our array example here. And this is, we're doing this here in the update. Why am I, no, this is example code. So here we're saying, hey, the origin is 0, 0, 0. It has a forward direction. And so it's basically vector 3 the point is get point distance of 13. So my point 13 units on the ray is going to be, again, it's going to be, since we're going down forward 0, 0, 1, we multiply that by 13, then the vector is 0, 0, 13. There is also, let's go back to the slides just quickly. There is what's called the debug draw ray, and want you to be very clear. It's a debug method to help you visualize rays in your game. Only works in your scene view. If you need to visualize a game in the game view, you need to draw a different way to draw the line. We'll talk about that in a moment. So debug.drawArray. In this case, it is float draw length. So we're getting a length of 25. The origin is going to be our game object position, and then the direction is going to be our forward out 15 directions, 25 units. The direction again is going to be our origin plus the forward vector times the draw length. And what we need to do is we need to tell the beginning and the end and the draw color. And hopefully, let's go in to file, make a new scene, basic built in. Let's put a cube in, 3D object. Place a cube. We'll put that at 0, 0, 0. Where is here's the Raycast folder. So here is the ray. So this is the ray example. So we're going to put that on the cube. And you can see it's drawing that line already. We'll get to Y in one moment. But again, we'll press play. We'll go back to our scene view. You can see that we are effectively drawing in the scene. All right, let's go to the slides one moment because the next. All right, so there is a metadata tag. It's called execute in edit mode. All right, so Unity has attributes that we can add to functions. We can add to classes. This is great. There's a attribute that'll make Unity run your code in the editor. Great for scripting components that draw debug lines in the editor. And there is, so let's go back and look at the code. In fact, this whole class has been tagged to execute in edit mode. So it is going to call update, it's going to call start, going to call update and do the code in here. And again, it's setting up the debug draw. Again, um, the the issue that we have is that the origin basically it wants a start and end point. Go down to debug, and I've not opened this up. Hold on. There we go. So is it's labeled as start and it's labeled as direction. It is really the endpoint. All right. Think of it as the end. The draw ray function takes the start and the endpoint, not just a direction. If you do not if you don't set this up correctly, then your line is not going to draw correctly as well. And we can go in, we can grab this object. We know that this is going to be okay. We can see that is rotating, it's moving correctly. We can rotate it, and you can see that line is now rotating. And this is basically a great way to help visualize where your array may be if you're having issues with a raycast. All right. Let's jump into the slides again. Let's talk about again. Raycasting is to define one or more objects that lay on a particular ray. Unity performs it by looking at colliders that lay along the ray, and there are ways to sort out what it only looks like. There's Unity has a layer system, which you can then sort out later on. You can look at and how to sort based on looking at only things on this particular layer. Unity has several versions of the methods depending on your needs. So there are 3 versions of Unity. There is Raycast, Raycast All, and Physics Line Cast. This version exists, but it's not really used very often. Raycast returns a backup boolean depending if you have an object found. Some versions include an optional out parameter to get Raycast hit information. So for our purposes, we'll look at the code right now. Basically, the idea with an out parameter is that we give it a structure, like the raycast it structure, and it basically shoves all the information that you want into that structure. And when we're done, you just basically can just use that structure as you provide. I'll show you this, and it's odd. It's odd. Again, normally the parameters passed are read-only. When we make an out variable, we're passing a variable for a function to modify. Function needs to be defined with the out keyword as part of the parameter, and we have to create the parameter, the variable that we're passing in as well. Now, raycast all returns is more straightforward. Returns a cast of raycast hits. If the array is empty, then nothing was found in the raycast. And advise to look through all the objects on the array as opposed to just the first one on the array. Query trigger action. Sometimes we don't want to deal with triggers. Sometimes we do. So this is use the query hit setting, ignore. Again, I'm looking at what some of these. So getting back to what we're talking about, provides collision information based on the raycast performed, and the structure is per collision. So if we've got multiple collisions, we've got multiple raycast hit structures that we're dealing with. Test if radii would collide with anything if it was moved through the scene. This is similar to doing physics raycast for all points contained on any rigid body colliders, returning the close of any hits reported. Great for UI and movement code. Say you need to know an object would fit through a gap. We're not going to really worry about sweep tests. There is rigid body sweep tests, sweep tests all. So these are things that we're not going to use, but you should know about that it's available to you. And then there's again the API for all of that. So let's just jump in. All but this. Let's bring up. See, this is the Ray example. So here's the Raycast example. All right, this update is really weird. Let me just fix that. There we go. Okay, let's take a look at update. So there's no start here. Um, there's a Boolean, and it basically says check for one hit or check for multiple hits. That's basically what it is. Um, we have a lot of information here, and a lot of this here is written as an example to show you in the editor what's going on. In all honesty, you're not going to be writing like what hit at point, hit at normal. There's a function down here that basically utilities reset editor publics, process hit. All right, you wouldn't be writing this stuff normally. All right, so let's go through. Let's look at single hits. And again, here's the utility reset the public. So every frame we're not dealing with all data. That's all that's doing. You wouldn't write this normally. But basically, it is a Raycast hit. In this case, I'm putting it into a bool has hit, and I've got physics Raycast transform the position. So the Raycast function is taking an origin, a direction, and this is just the direction. Again, the origin would not be part of. So this is the case where it's the actual direction, not. So this would be a vector around 0, 0 from the origin 0, 0 going in its direction, as opposed to transposed to where it is. So where is it starting in the world? What direction is it going? This is essentially basically the version we're going to use here is going to be out hit. So this is the variable that we're going to shove our information into. And then how far are we going to go to? Because ultimately we don't have to go to infinity. And in fact, we don't really want to go infinity at times. So this is something you would write your code. This is literally how you would write your code. Now you'll see a lot of times the Raycast physics method get put right in here. Um, it's not really for me. I'd rather have a Boolean. This reads much easier, so that's how it's being read. But you'll see this shoved in here, right? So I've got a utility here about process hit. So we know if we have a hit, then this variable hit has all its information. So collider. So what is the collider that we hit? In fact, if we go to collider, we can get to the game object. The hit has a point, impact point where the ray hit the collider. There is the normal, which is the normal of the surface of the ray hit. So this is basically the orientation of where it hit on the object. Or else, distance from the ray origin to the impact point. So how far from the origin did we hit that from? So if you were doing some sorts of stat stuff, this is important stuff. There's like, hey, light map. Did we hit a rigid body of the collider? Transform the rigid body of the transform the rigid body or collider that was hit. And there's other things like triangle index and texture coordinates. Like, sure, that's helpful. But the big ones again is going to be the collider, distance, um, point, and normal. Those are the 4 that you're going to be using on a regular basis. This is just basically a utility function to basically take what's in hit and push it into the editor variable. So let's take a look at this. So process hit has found object is going to be true. The found object is the collider's gamed object name. Hit at point, hit at normal. Again, hit point, hit normal. we will. I'm not. We'll just save. Let's go back to. All right. There is a sample scene provided in this, and basically it is this clock setup. So 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's basically a clock. We've got a object in the center here that's going to be circling around. So it's going to spin. I have, here's the raycast example. This is generating, what's generating the red line. And then we have the raycast example. So as we go through, I'm going to start right now just showing it's going to hit what it's hitting. And right now, let's go to the scene view. You can see that. I'm going to pause it. So it's hit cube 221. Where's the point? What is the normal on the cube that it hit? Now I can check for all hits. In this case, if I do that, I advance it. You can see it hit cube 1 2, 1 1, 2 1, 2 2, 2 3. I'm gonna go back. I'm gonna pause. And we're gonna advance. We're gonna take a look at the line as we advance. So again, as we get closer to it, you'll see because of how the distance. Again, it hit 3 1. And it's only hit 3-1 so far. The line is going past these two cubes. We go, we'll have 2 and then ultimately 3. And then if we go a couple more frames, the third one goes away, based on the distance and how the line is curved around it. So let's take a look at when we have multiple hits. Again, I'm clearing out the publics. I'm clearing, and I have this found object list. Again, this is just a list. You wouldn't be doing this normally. Um, in this case, I've got again a raycast array of hits, which I'm assigning to the physics raycast all. This is a case where I might actually assign this right here. I might not actually do 2 lines, but I'm actually doing. I'm gonna actually go break the line just so you can see this all on screen in one place. So position, look, so the position, the direction forward, and check distance. And again, I'm using transform.position here, and I would be using game object. I'm not doing it in this case because of both the slides and for basically screen space. I'm leaving that off right now. You can, but I would not normally do that. And so basically, I am going through for each object that hits. And if there's nothing in this, it's not going to do anything. In this case, it's processing which hit it got. So the last hit it got is going to be the one that's going to be displayed in the editor. But you'll have all the object list added, the names. And again, the object list is a string. So I'm just getting their names and just adding the strings to show in the editor. Again, normally I wouldn't do this, but this is for the example. Again, the core here is that this is the core of the code. You have an array of hits. You're going to do the raycast, and then you do for each hit in hits, and the code you do in here for each object. Again, I'm just this processing hit stuff. You wouldn't be doing normally in this particular way. You wouldn't be using this like process the hit and do something in the editor. You wouldn't normally do this. So I want to make sure you understand this is here for this example, but it's not normally the code you would do. So if I see utility reset editor publics, utility hit process hit, then I know you've written your code poorly. It's not the code you need to do. Like check the of these, I'm gonna just point out that this is the one variable that you would want to use in your code. Check for all hits. And this is example code. All of this is example code. How you do the update here is example code. So so let me save that. Let's jump to our scripts. Go back to lab 6 because we're still in the so we're gonna go so for our purposes we're gonna go back to our combat player. We do not need to know how big the grid is. We don't have a grid anymore. One of the things that we will do is we'll have a public float raycast distance. And I'm going to set that to 25 for our purposes right now. For convenience sake, we are going to continue using the barrel end for our calculations. All right. So I'm going to save this. I'm going to jump into update, and I'm going to write a function. And I'm just going to call it draw, capital D, draw debug line. Actually, let's just use the draw line. For our purposes, again, it is start, end. So it's going to be barrel end dot transform dot position. Actually, I'm going to do this. I'm going to do this. Yeah, I'm going to do a draw. I am going to actually write a function. Hold on. So it'll be a public void. Oh, put a D on void. And I'm going to use a vector3 start, and that's going to be the barrel end. It'll be vector3 direction. I'll do end. It's going to be start plus our game object transform. We'll use the forward vector again times the ray cast distance. And just that alone, this will make our start and color red and not duration. What is the correct version I want? Oh no, that is what I want. I'm thinking I have to add the distance that's built into the endpoint. So we'll save that. We'll go back to now. Let's just go. We need to jump back to our combat scene. Where's our tank? Here's our tank. So if we press play and we go back to our scene view, you can see that this is the raycast line that will be casted. All right, let's go back to our script. So we know that that's up and running. Let's jump into, so if you haven't already, make sure that you've enabled the east button and Fire2 is enabled, and you're going to call the Fire2 function. Fire2 is going to basically call perform raycast. So let's write the raycast code. So we know that we're going to have a raycast hit and use the variable hit. This is pretty much normal. Now it's yelling because we haven't initialized it and we haven't used it yet. We will in a moment. We'll do a bool has hit. And it's going to be physics dot raycast. And there's multiple versions of the function. Again, the version that we are going to be using is, yeah. So what we want is version 12. So it's the origin. So that's going to be, again, origin, direction, raycast hit information, max distance. So the origin is going to be, again, barrel end dot transform dot position. And I'm going to do this on multiple lines because we're in the barrel end dot transform dot forward, and it'd be out hit. Again, we have got to use the word out, and then finally it's going to be our ray cast distance variable. And if has hit, found, and we're going to hit dot collider dot game object. We'll just say its name, and this will be debug dot log the message. And we could do a lot. There's a lot more we can do here. But the thing, why we're doing in this again, this is again, fire 2 is going to happen when we press either the E key or the O key, depending on the player. So that's our. So let's just save this, and we'll just jump back into, and then I've hit the outer wall west, hit the outer wall south, hit the east, north. So let's just, for sake of argument, let's put in 3D object. Let's do a cube. And we're going to put these basically into the scene. I need to move this up. So I'm going to put that over here, if it will let me. I'm just going to, put another 3D object. And again, you wouldn't normally be doing this. Again, I'm just putting things into the scene just so that we have things. And we'll make this size of 2 again. I'll put that right here. I'm just going to do object sphere. Again, we can go back in. We'll use the scene view to line up our shot. So I hit the sphere in there. Oh, let's go up closer. So I hit the cube. My tank is putt-putting along. I'll hit that cube. So we can see that I am hitting things. Let me just check the lab document. Again, we're adding the second fire raycast determine hits. And again, we're just putting to the console what you've hit. Create a prefab to spawn when your raycast hits something. That's extra credit. Use a particle for the raycast hit prefab. So our purposes, we're going to create a, hold on. Let me grab this here. I'm going to duplicate it. And I'm going to make this 0.5, 0.5, 0.5. And we'll go into common assets and we'll make that red. And we'll just call this hit marker. And then we're going to go back. Where did we write it? Was it in Lab 6? I'm going to hack. I'm going to use basically, so here's our hit marker. I'm going to make it essentially a combat projectile with a move speed of 0. Give it no damage value, and then we'll do a lifespan of point. I'll do 2 seconds. Okay. This is a little bit of a hack. So I'm going to grab the hit marker. I'm going to put this into, I'll put it in combat for right now. We'll make an instance of that in here. And now that I've got that, you will see that the hit marker will be in the scene and it's going to go away in a second. Should have. Nope. All right. I'm going to go back. So, all right. I'm doing this the hack way. Again, I need to add a component of the rigid body. In our purposes, we don't want to use gravity. Actually, I don't want to use the combat projectile. Let me undo this. Let's do this the correct way. Let's break. Let's unpack completely, and let's delete this. Yes, delete. All right. Let's go. Let's make a new script. Let's go back to the lab 6. Where is scripts? Lab 6. And we're going to just basically create a new model behavior script. We're going to call this lifetime. Won't need update. All we need here is basically one variable. It's a public float lifetime. And I'm going to set that to two. And then basically it's down here in start. It is going to be a destroy call of the game object and the lifetime variable. So we'll save that. We'll go back to go to Unity. We'll actually use the lifetime script as as I should have done. So I'll press play, and then after 2 seconds, you saw that it's now disappeared. Cool. So let's go back to the combat folder, and we'll just drop the hit marker in here. Again, I'm showing you off the extra credit for this week, so you should be able to do it. So let's go to our script. So the first thing that we need for our combat player script, where is it? We will put a public game object hit marker prefab. And then down here on the perform raycast. Ultimately, what we'll then do is we'll be instantiate. Again, the object is going to be the hit marker prefab, and it's going to be at the. We're going to use the hit dot point. Let's go to the correct, and it's going to be hit dot normal. This is normal. This is it's looking for hit dot normal. Again, the issue is what the we need a quaternion. Quaternion. Uh, yeah, Euler. So we need to put the normal, which is the vector 3, through Euler dot quaternion dot Euler. So this is how you convert the quaternion from the quaternion, which is 4 values, into x, y, z and vector 3. We refer to now the thing about Euler. So Euler basically is yaw pitch roll. That's what that means. The problem with using Euler coordinates is that when you get around 0, things get funky. You get what's called a Euler lock because values around 0 uh, act funky. And that's the thing that with a quaternion you don't get that locking point. Like if you get a value on 0, then you've got an issue of like any multiplication is just a flat 0 no matter what happens. So you don't get that with a quaternion. Also, quaternions mathematically, in terms of how you can calculate them, are a lot faster, and it's using what is referred to vector math. And I know we've used the term vector. Vector in mathematics means something else as well. And so that's under what would be linear algebra. If you guys are curious, if what's going on underneath the hood with the quaternion. But basically, we're going to just basically create our. Basically, we've got our prefab. Here's the point. Here's the normal. I'm going through and using hit dot normal, but I could have done quaternion dot identity because I'm using a sphere. So I'm going to save. I'm going to jump back into the game, go back to Unity, go back to my player 1, and I do need to mark the prefab down here. So we just grab that. Again, prefab's coming from the assets folder. So I can actually now remove the marker from the scene, and I can go through. Oh, and it'd be nice if I was, you can see that. And it is stacking upon each other. Let's go to the prefab. Let's stop. So what's going on? It has a sphere collider, which let's take that off. So now they will stack in point. So it's stacking on the point that where I'm hitting, as opposed to I'm actually going to change up the document. I'm going to actually have you use these hit markers. And you can see they are getting destroyed as time goes on. So that is pretty much, again, this week is about learning about using the raycasting. And this is a week that if you're behind, this is a week that you can, again, there's not much here. And again, let's look at our code. There's not much here to perform raycast. I mean, would be one line normally. So it's it would be written like, so this is how it would normally be written. For our purposes, again, for being on the screen on the projector, I can just do two lines. That's better. And you can, some cases, again, some cases this gets thrown in, rather than doing a Boolean hash, this gets thrown right into the if statement. That's a common way you'll see this written. So don't be surprised if you do. But again, here, like I'm putting, this is part of the lab. I create the string, and then again, I will create variables for my use to make things easier to work with. So rather than, I know I could have shoved this into the debug.log. I found this, if I wanted to just play with this and work with this, I can do so at my leisure and then take that and shove that into the log. Here's instantiate, setting things up. We can go and actually go back to Unity. There is, again, a folder under combat of icons. Let's go and grab, here's player one. Instead of being those markers, I've got this explosion marker. Let's go back to player one. Let's set that to be the marker. Let's try that again with, I thought I'd stopped. Here we go. And it also has collision. So it's seeing itself. The other thing is that the explosion, where is, yeah, here we go. Add the lifetime script to it, and I'll turn off the box collision. So yeah, you can see now it's not stacking on itself. All right. So we talked about, hey, well, how do we display the raycast in the scene? So for our purposes, we're going to create an empty game object on our player, and it's going to be laser control. And the laser control basically is going to have a 3D object of a cylinder. And we're going to parent the laser control to the barrel end. And we're going to set that to 0, 0, 0. All right, let's take the cylinder. First thing we need to do is we need to turn it 90 degrees. And we need to move it forward 1. So that the laser control is the root of it. Now, we have a big, thick, meaty laser. That's just basically, let's take our cylinder and let's bring this down like 0.2, 0.2. We do want to maintain, so here's the cylinder. We want to maintain the cylinder length of 1 so that we can multiply that out. What is the capsule? And we will get rid of the capsule collider because this is basically going to be a visual component. We're going to go back into assets, common, and I'm actually going to go to the pure. I'm going to go to, we'll set that to red. And there are options. We can make it glow. There's other materials we can say, but like, make it glow, make it transparent. Actually, let's do that. Let's go to combat, and let's make a new, create a material, laser material. And rather than the rendering mode, let's go to do like a transparent. We'll turn on emission, and the emission color we're going to just basically turn, that's going to be red. And then we will basically set this value to be a red, but we'll set the value here to be like 128. So here we go. So that's not showing up as well as I thought it would. It's not glow. It's not glowing as we would think it would be. Can I go to, what was that? Which emission color? No, the emission color is basically. Oh wait, I need 255. There we go. Um, so I need to go back to my albedo here. I need to do 256. Do 200. Give it just a slight. And this is something you again. I'm playing with the built-in stuff right here. Again, you'd write actually a shader pipe. There'd be like a shader that you would actually write. Metallic, use albedo alpha, smoothness. It's not metallic. We'll worry about this later on. Um, so here is I've got my laser. Um, let's go to the laser control and let's actually again let's go back to the we know the scripts and we'll make a new model behavior strip. We'll call this laser control. All right, we'll put that on the laser control, and let's go actually go in. So first thing that we do need to know is game, a public game object, um, laser object. And the next thing that we want to know is a public vector3 laser size. Do we want? We may not need this, but we'll leave this in place here. No, we won't need this. We won't need this. We just need the laser object. Um, we need a public float show time. Show laser time. We'll do half a second. Public float. If I can spell things correctly. Laser time. Sorry. Show laser counter. And this is actually not public. So in start, basically, do we need anything in start? No. But we do need a public show laser. And we need to tell it the distance. So this will be a float distance. And this is going to be a void. All right, so the first thing that we are going to do is basically the laser object set active true. So we're going to show the object. Actually, we're going to do a void. Actually, do void start. And so we'll actually do set laser object false. All right. We're going to do the show laser counter is going to be equal to the show laser time. So basically, we're going to count down. We're going to count the counter down to 0, and when we know it's 0, we will turn it off. And then the last thing that we need to do is basically as a vector3 scale. And it's going to be equal to our laser object dot transform dot local scale. And then we know that the scale dot y is going to be equal to our distance. No, it's not going to be. It's not going to be the laser object. It's going to be our game object. We're going to scale the root, and that's going to transform the object. It's going to be equal to the distance, and then again, game object transform local scale. And I should really not use this as scale, but rename that to new scale. I'll call it value. So let's do the counter. So basically, if show laser counter is greater than 0, next thing that we're going to do is show laser counter is minus equal to time dot delta time. And then if show laser counter is less than or equal to 0, time's up, hide the laser. And we know that basically we'll just set this to false. So we set active, so we're going to hide the laser. So again, when we call, then again, this kicks off by show laser. Shows the laser, sets the counter, sets the scale that we were telling it to use. So show laser distance of x. On update, basically, if the laser counter is 0, it means it's still active. We'll reduce the time. And we'll hide the laser. So save that. So let's go back and we'll go back to our combat player. We're basically going to we're going to make a variable public laser control. We'll just call it laser controller. And we will go back, literally we'll go back to Unity now. Go back to our player one, and we're just going to grab this object and place it right there. So now we have that reference to the script. All right, we'll go back. And then we'll press play, and you see right away. Why is it still there? Laser control script. Why did it not hide? Oh, it's because in the laser control script we didn't sign the cylinder. There we go. And we should really not be cylinder, it should be laser object. Actually, not laser object, should be laser model. So now if I stop and redo all that again, laser object, laser model, we'll sign that there. So if we press play, it should hide it now. There you go. So it's hidden. Again, what we haven't done yet is now that we've got a reference to the script, we can now go back to perform raycast. We can then actually now do laser controller, show laser, and this is going to be our hit distance. We'll save, and then we'll go back to Unity now. We press play. Why didn't it scale the child? Turn this on. and I've scaled it wrong. I've scaled. I've got a big beefy laser, but it's the wrong. So I've done the wrong. I've done I think Y I should have done. It's done. It's going. So let's go back to the laser control. I did new scale dot Y. There should be new scale dot Z. So down the forward axis. So let's save. So wasn't doing the scaling. It was just on the wrong axis. So let's try this again. And you can see now. So the one problem, it's going through stuff. Why is that? I'm gonna undo this. I'm just gonna basically, I'm going to unbarrel, I'm going to, hold on. I'm gonna put the laser model, parent it to there. Yeah, I think the issue was I parented things into the barrel end. I should have left this yeah, laser control 111 model. Yeah, let's try the I think there was a parenting issue. There we go. No, it's still going through. Um, why is it giving me weird values? Of course, you can hit your own projectile. Now, the issue right now is that they're not interacting with things. And that, don't worry about that. We will correct that next week. I'll have to figure out why the model is acting weirdly on me. Why is it giving me a distance of 6? That's a good question. It is scaling correctly. This is the. Does this need to be half the size? Nope. There we go. Okay, so I think the cylinder is actually a length of 2. Yeah, that has to be what's going on. So the cylinder you get is a length of 2, so I had to bring it half the size down and move it up half the unit to basically be on its route. But again, this is all extra credit, so don't worry. And you can see that as that laser basically that is going to it's going as I'm rotating, the laser's going along for the ride. So that's more of a laser control. Well, how long? Like a tenth of a second. So it's more less noticeable. So things that to think about, how we would construct things, how we would build things. Again, I've gone above and beyond what would you would need to. Continue working just in the Lab 6 folder. I know that it says Lab 7. Don't worry, I'm going to go back and update the assignment to just basically say just continue working in the Lab 6 folder, because basically you're updating for the most part the combat player script to now use a raycast. If you were behind, you're just starting the combat. You've got all week. You've got an extra week to get things up and going. Not in terms of the assignment, but more basically. I mean, like I'm not going to be. If you need more time to do Lab 6 to get that last piece done, I'm not going to worry about it. But you should by the end of this week, by end of Monday, you should have Lab 7 done. Right. The next piece, Lab 8, we're going to talk about object interaction. So, like when the projectile hits something, it's going to ask, is it a player? Is it this? Is it that? We'll have the raycast, like when the raycast hits another player, it will do things. When the raycast, we'll actually have the raycast if it hits. We'll have the raycast basically tell the projectile it's been hit, and if it can, it will destroy the you. So you can shoot other you. So we'll enable shooting with the raycast shooting projectiles. Gives it a mechanic. Now you now have defense. Maybe you add that and you have multiple raycasts coming off of the object. You've got multiple raycasts coming off that act as your defense, like chaff or whatnot. There's gameplay opportunities here for you. But basically next week we're going to bring this together. You'll be able to reset the player back to where you started from. Um, Keep score on the player for the most part. You hit someone else, you get a point. Someone else hits you, they get a point. Any questions about this week's lab about raycasting? Okay, I'm going to stop the recording right here and upload it to YouTube.